Hey guys, welcome back to my workbench on our project our receiver. You see in front of you, see a capacitance meter I built a while back. Let's see if you can see. I'll put some light on. Well, anyway, this is this switch down in the down position gives you in picofarads or microfarads, and the up gives a coil. So you can put a coil in between this, and that will tell you exactly what the self-inductance is of that coil. Alright, it's now it's back on. I really can't see if you can see it. Anyway, I hope that you can see it. I have no screen to check this, so I have to rely on that you are able to see it. I think that is better, for you as well, because you have to look at an angle at that screen. Okay, you can see if we go up, there's that spool, that means coil, and you can put a coil in between here, and you can read the self-inductance of the coil. Alright, you can make this kind of appliance for yourself. Just you have to find it on the internet. If you are in the Netherlands or in Belgium, you probably will be able to find it somewhere in Maastricht or something like that too. Because one of the has a little print or so whatever with the parts, so you can put it yourself together. So I built that back in 2008 to 2007 or something like that. So that's quite old, but that serves me nicely. So, and then the second appliance what I have here is a grid dipper. Let's see if I get it in the screen. And you see the little coil on there, and that coil is 7.5 megahertz to 11. So now I get straight to the point. You need actually a grid dipper to measure a coil like that, so you can see the resonance frequency with that meter. So we do that in a bit further on, in a little while we'll do that and we do some checking. Okay, my first thing I'm going to go down to what I want to talk about. First of all, I will take the coils. This is for the 40 meter band. See, I can put that there. You can see it's 5.665 megahertz to 7.6, and this one is 7.5 till 11.5 megahertz. All right. And I have another one set here that gives you 2.7 megahertz. Let's have a look. It's 3.7 to 4.2, and this one is 3.8 to 5.9. That's 80 meter band, okay? Anyway guys, we had it on a coil, and I'll show you again. There he is, and this is a 2-inch drain pipe configuration with 25 turns on from 19 wire gauge. So I put some taps on there already. I changed the tap configuration. Let's have a look here. I have to turn them around. Sorry. I had a tap here. Let's have a look again. Here on this point earlier on in the previous video. I moved that tap down to let's have a look, the third turn, the third winding here. I put them on there for the 80 meter. I calculated that as about 8 megahertz here, and you go down and you divide it by let's have a look at 1, 2, 3, 4, 5, 7, 8. I divide that through 8 is 1 megahertz per turn, so you want to work at 3.5, 3.8, and the tap will be okay on the third winding or the third turn. Okay, so So that should be working nicely. I have another tuning capacitor. I did find it in my box, and that's 100 picofarads. And I did also what I did also is making the tap for the 40 meters. This is 80 meters. The top one is the 80 meters, and this one is the 40 meters. Okay, I made the connection already on the capacitor for the 40 meters. So you can see this is the second one onto, and I did some dipping as it were. It works out that this minimum stance of this 100 picofarad capacitor is around about 10.5 megahertz. So you have to go back to 25 picofarads to go to, if I'm not mistaken, to 7 megahertz. So this minimum stance is 10 megahertz, 10.5 megahertz. What I'm going to do now is to employ my grid dipper, and I will go and find out where this minimum stance is about 10 picofarads or something like that, yeah, 10 megahertz. Again, coincidence, could be 12, could be 15. I didn't measure that with my meter. You can see here the meter is on 10.5, 10.6 is actually what we're seeing. If you look at our meter here, and I put them on there, and you see the meter dropping down. You see, it's dipping that he is there. Okay, so we're sure in that stance we are at 10.6 megahertz, something like that. Now we're going to put that meter on to 7. Let's put that 7 megahertz. So we can't reach that because we have to use another coil. I'll switch them off. Yeah. Pick up the other coil. So this is 5.8, say for 7.6. Then we are at 5 megahertz now. Now we go up to 7 megahertz. That's around 6.9. That's about close as close we get. We have this meter at maximum. Now it's a bit tricky. See if I can get this into that you can see and can follow, but that will be difficult anyway. So that's what I will do is get them in the right position, the capacitor. I'll put them on there for a minute. See if I can help myself. Hold on. Put the parts away. So put that on there. And I will turn that capacitor maximum depth. Now I'll show you that on this side. Can you see it? Yeah, you can see it. You see this capacitor is only slightly turned in, so you can see how little capacitance from it is from 10 megahertz to 7 megahertz. So that will be not even 20 picofarads, something like that. And we already, I can show you that hopefully without it's always difficult, eh? Just heavy and oh well, let's try it, see if we can show you. If you can see the meter, and you see him drop in, you see? That's why a dip meter is so handy to have. So you can actually see in advance what kind of capacitance you have. What you have to do next is then measure this capacitance, this with the lowest frequency. You have to turn them up again, so less capacitance. Now probably you start to understand why I want to use band spread. You can see how much is left of the capacitor. You can see that, how much room is under that capacitor, so you have very little room to tune. So you can, it's going to be on a very narrow nippy business. It's very small. It's about 4 or 5 picofarads where this is going to tune. Well, it's not a very nice way to do it, because you won't be able to tune this properly. And as you can remember perhaps from the previous video, you could use, if you measured this, I will measure this and I will tell you straight what it's going to be, because I assume you don't have a grid dipper, and I have to show you. So what I want to do is work out exactly what is your maximum capacitance from this tuning capacitor and the minimum capacitance what you need to reach your band. So from 7, which, see how that goes, to measure that exactly from 7 megahertz to 7.2 megahertz. The same is true for the 3.5, 3.8. So that gives you a minimum capacitance and a maximum capacitance. What I also notice is that this tap is only one turn different from this is on the 80, the tap is on the 80 meters. There's only one tap lower down for 40 meters. As I said in the previous video, I'm going to leave it there. So we see how it works out, if we can tune it properly. And you always can change that, but we're going to leave it at that for the tap, and we're going to switch between 80 and 40 meters. That's what we're going to do. So I will work out the capacitance, what you need minimum to have the highest frequency, and the maximum frequency, the maximum capacitance. So maximum capacitance for your 7.0 and 3.5, and the minimum capacitance for 3.8 and 7.2 megahertz. So the capacitance, I will measure that with this meter here. It's quite easy to do, but there again I have to solder this off and on and off and on, so that is a bit difficult on camera, so the video will then too long, and that's not what I want to avoid. So I will do that off camera. I will inform you exactly what's going on here. So having said all this, you know now how to go about this. The only thing you don't know is how you do the band spread. Again, there is a video on my channel what explains that a little bit. See, I am not a teacher or anything like that, so I can explain it clearly for everybody, but then we can try to understand what I'm saying, and try to follow along. And if you don't get it the first time, perhaps you should play the video a second time around until you know exactly what I'm all about, okay? So that's my advice to you. Anyway, if you don't want to know all that, then you just follow the video along, and you will find out at the latter part of the videos what is done and how it is done. Okay? Having said all this, then we have to make antenna coupling. Okay? The antenna coupling comes always on the bottom part of the coil. So it's not on there yet, so we have to fix that on there. It doesn't have to be necessary the wire gauge 19. You can use another gauge that's a lot thinner. It will work. So and then you only have to find out how many turns you need for that. Now it's not rocket science. It's probably 4 or 5 turns, something like that. So if you use the half thickness of the 19, then you get a long way. You have to drill a few holes in there, 2 of them, and then fix it on there. Now we're going to the part I mentioned in the previous video. This part is, well, it's an oscillator actually, and it's not an oscillator. It is built like an oscillator, but it doesn't get the oscillation because it's on the verge of oscillation, so just on the edge of oscillation. And it is possible that it's going to oscillation that it will give a signal out on the antenna. And so far as I know, it is not allowed to do that, and certainly not if you not have a license for a transmitter. So you're not allowed to do that. So for those who have not a license for a transmitter, I suggest that we put another valve axle in there, and that will be the EC92. There's a little triode, and then we configure that way with a potentiometer that block that signal. If it goes into oscillation, it will block that signal and it won't go on to the antenna. That is a possible point. Anyway, that is up to you if you want to do that. It is a bit more work, but it will work perfectly. So it will prevent the signal go on to the antenna. Anyway, so so far so good. Then I showed you how you can do this. That is all the thing I have to say in that video. So what we're going to do next is put it all together, I suppose, and get the mountings ready. I didn't do anything on that transformer yet, so I will do that also. Anyway guys, if you like the video, give me a thumbs up. I try to get help you along, see if I think it's very nice if you build your own radio, that the thing functions, and it's nice to have, and that you have something to be proud of. Okay. Anyway guys, you don't have to use this kind of coil. Probably I will find out. I think if you are on the 80, 85, 90 microhenries, then you can make a coil for the broadcast band if you like. This is possible as well. Only what you want to have is then a bigger capacitor, I suppose, to go lower down in the frequency, so that will be in the region of 350 picofarad, something like that. So I'm just talking out of my head, something like that. So I have some experience. I know where it should be. I think it is what it should be. I have to look it up on the chart. So anyway, I'll get back to that. I'll tell you that probably in the next video. What you could do, and this the wiring gauges then a lot thinner, of course. You have to. There are programs on the internet. You can calculate that with that programs. It's not that difficult. So, but for those who are like calculating, you can calculate yourself. Also, those videos are on my channel, so everything is there. There's even another little video there about another regen what I built with one little valve, but also with an EC92 for blocking the signal to the antenna. So perhaps you can have a look at that. That will be an education for yourself also. Anyway, I hope you liked the video, and I will get back on that last part of the broadcast band. So anyway, making the coils smaller, so less turns, the frequency will go up. You can go up to 20 meters. And I'm afraid, guys, above that it can become a bit more tricky, because all the length of the wire is going to play a part in your frequency. So this little wire here has a self-inductance, yes, and if you are higher up in frequency, this is going to play a role in your tuning. So, but stay at the high frequency bands, that's what I recommend, or lower, go to the broadcast band. and make your coil, and take it from there. Make sure you have the right coil capacitor combination. That has an influence as well. So anyway guys, I'm not going to elaborate even more further than that. So I hope you liked this little video, and give me a thumbs up, and I'll come back to you with another part, okay?